Newton's cradle was invented in 1967 by English actor Simon Preble and named in honor of scientist and mathematician Isaac Newton because it employs Newton's laws. In 2011, on an episode of the Mythbusters attempted to create one of the world's largest Newton cradles. You've probably seen this contraption before. 5 small golf balls hanging in a perfectly straight line by thin threads that attach them to 2 parallel horizontal bars, which are in turn attached to a base. They sit on office desks around the world.
When a ball on one end of the cradle is pulled away from the others and then released, it strikes the next ball in the cradle, which remains motionless. But the ball on the opposite end of the row is thrown into the air, then swings back to strike the other balls, starting the chain reaction again in reverse.
Newton's cradle aptly demonstrates the principle of the conservation of momentum. This principle states that when 2 objects collide, the total momentum of the objects before the collision is equal to the total momentum of the objects after the collision. In other words, when the first ball of Newton's cradle collides with the second, the first ball stops, but its momentum isn't lost, just transferred to the second ball, then the third, then the fourth, and so on. You witness this conservation of momentum as the last ball swings into the air with nearly the same momentum as the first ball. Thus, if 2 balls are lifted into the air on one end of the device and released, then 2 balls on the opposite end will swing in response.
This continuous clicking of balls is also proof of Newton's law of the conservation of energy, which states that energy can't be created or destroyed, but that it can change forms. Newton's cradle demonstrates this last part of the law quite well, as it converts the potential energy of one ball into kinetic energy that is transferred down the line of balls and ultimately results in the upward swinging of the last ball. But why do they stop? Just because the cradle at some point stops moving does not mean that it breaks the law of conservation of energy. Energy is still conserved, but in different forms. As the golf balls are in motion, friction builds up, and friction reduces energy. When they compress, then decompress again into their original shapes, the friction between the molecules inside the balls convert the kinetic energy into heat. This heat is released into the air and produces the clicking sounds. Energy is lost.